Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this video, we will analyze a conference call which actually uses SIP and RTP and see how it is different from the two caller as well as the voicemail one we saw before. Okay. Now, the key thing to remember is every caller at least has two streams, right? Which is between him and the server. Now, as we've added the third caller, this increases the number of streams by 2. And now the whole system has 6 streams. So where each of the callers, Bob, Alice, and John have 2, and the server has as many as the number of callers. So the rule of thumb really is number of callers into 2 equals the total number of streams. So if we had 5 callers, then there could be a maximum of 10 streams to monitor. So now let's actually jump right in and look at the data. So I'm going to go inside the SIP RTP folder. And I'm going to open up conference call 3parties.pcap. And I'm going to apply a filter for SIP or RTP. Now let's click on telephony, SIP flows. As we understand, that is the starting point to analyze SIP traffic. Let's end up selecting all of the flows. Click on flow sequence. Okay, so now this ends up giving us this flow sequence diagram. Now we can see we have the server at 20.130, right? We can see port 5060. And you have one of the VoIP clients at 20.132, one is at 20.1. And if we scroll to the right, we can see the last one, 20.136. Now, as I showed you before, you can name all these IP addresses as Bob, Alice, and John and the server. I'm going to leave that as an exercise to you. So let's analyze what is happening in this PCAP. So first we actually see that each of the phones are going through the registration process and informing the registry service of the server that they are available and online, right? So we can see that for 20.132 all through from here to here. Then we have 20.1 exchanging these initial packets up to here. And then the last one, which is 136 up to here. Great. Now after that, we see that 20.132 is initiating the call to the server. And we can clearly see that the call goes through and finally RTP data is exchanged between it and the server. Similarly, we have the other two clients. Here is where they connect to the server, RTP exchanges, connection to the server, and RTP exchanges. And finally, after the call is over, we end up seeing the bye messages. Here you go, all 3 of them. And after the connection to the call is over, all the 3 clients once again re-register just to tell the server that they are available for future calls. Okay. Now, one important thing, as you realized, is when we just see 2 of these RTP, we shouldn't be mistaken that there are only 2 RTP packets. There is really a bunch of them. The key thing to realize here is only that RTP communication or voice communication has begun. Now, in something like a conference call, you may actually have people coming and joining and leaving at arbitrary times. That is important to keep in mind as well. In this call, what we've done is we have recovered for all 3 parties. Again, unlikely in the real world where you might only get 1 party or depending on wherever you're collecting the trace file. Okay, but this is great for learning. And of course, if you are doing this in the field, all you would see is 1 party, and that's fine as well. Everything we learn is pretty much going to be the same. So let's click on play streams to see how the streams get plotted. Here, we can actually see there are 6 of them here. 6 streams as expected. Let's try to play this. And if you notice, we weren't able to play it for some odd reason, right? We can see that the bar starts somewhere over here, but seems to exit. Now this is very common for Wireshark. Now I've seen even with the same Wireshark, when you redo the experiment later, it might work. It has varied differences even across different versions of Wireshark, right? But the key thing is, hey, we already know other techniques by which we can go ahead and get the voice data packets out, and that's what we would ideally want to use. So now that we've understood this, let's do a call recovery. So I'm going to go inside my workspace directory. I'm going to copy my conference call 3 parties here. And then I'm going to run the pcap to wave tool, which we've downloaded and installed in a previous video. Give it the conference call 3 parties and provide it with an output file. Let's call this conf call output. And we can see that it automatically figures out that there are 6 streams, and it is extracting each of the streams as a wave and a PCMU file, right? Now this extraction will take some time, but in the meantime, we can start analyzing some of these packets. So VoIP class, sample calls, siprtp, workspace, and let's see conf call. Here it is, conf call out. And we can actually see that the wave files are being created. Here, the wave file has been created. Let's play this. Now keep in mind, this is of any one of the streams, right? So it could be to, fro, and the voice data could be anywhere, depending on where the caller actually says something or where the IVR automatically puts out a response. There you go. Now similarly, once this completes, you can look at each of the streams as well. Now, one of the other things I wanted to touch upon is the port numbers. So I'm going to click on telephony, SIP flows. Let's look at each of the flow sequences. And now let's actually look at the SDP packet and see the media description section, so we can make sure that all the port numbers are something we understand and the allocation and all of that. So to do that, I'm going to go down and select the invite SDP packet after successful auth. So this is the one from the first client to the server. And if we expand the packet, the media description section, we see that the client's port number is 4000 as expected. Most clients use a default port of 4000. The server's port is in the 200 OK SDP packet. And we see the server says it's going to use port 11946. And that is something we can verify pretty much right here in the next step when RTP data is being exchanged. Fantastic. Now here is the second client's invite SDP after auth, and we actually see that the port number is again mentioned as 4000, and then we have the server response back to the client, and the port number the server is choosing is 132.56, and you can clearly see that 132.56 is what the server is using. Now let's look at the last client, and the last client is this invite SDP packet, again 4000 port number for the client. Server sends the 200 OK SDP, and the server's port number is 15614. You can see that is really what it is using, right? Fantastic. So this is how you can look at VoIP traffic and make sure you understand it inside out, right? Now in the next video, I'll actually show you how to take all the wave files, which we are still recovering, and actually put them in a coherent manner so we can understand and work with it. Something we unfortunately couldn't do with Wireshark. And for that, we're going to use a tool called Audacity. So that's all I had in mind for this video. If you're enjoying your time at Pentester Academy, please recommend us to your friends and colleagues. Thank you.